So my name is Michael Godeck. I'm a business analyst is my current role. I've been a developer for a long time, since like Ronald Reagan was in office, something like that. I currently work for App Novation for a client I can't mention on air. And so I've been thinking about this process issue really ever since the very beginning, right? I've been struggling with this. And so these ideas have been kind of coming together. And so I'll start with kind of this little, I had this incident a couple years back where I went to a doctor because I had a cough. And it was a new doctor. I'd never been to her before. And I went into this doctor's office and I got in there and she didn't look at me, nothing, no observation whatsoever, wrote me a prescription for antibiotics and sent me out, right? And so obviously I went and found another doctor. I never went back there. But, you know, for some reason, when it comes to like Agile experts, right, they see this like time and time again where you have somebody comes in, doesn't make any real effort to make observation about the nature of the team, the kind of problems they're having, what their issues really are facing, and they're up there and they're going, well, you know, you're going to be doing all this and it's going to, you know, whatever. It doesn't make any sense to me, right? Because it all has to start with observation. So, you know, the whole problem of best practices is really captured by this quote by W. Edwards Deming, and so we'll talk about him a lot. Deming's he's the godfather of lean theory, I guess you could say. And so he has this quote, every theory is correct in its own world, but the problem is that the theory may not make contact with this world, right? It's great, right? Test-driven development, wonderful practice, right? Is it actually what we need here and now, right? So just because a practice worked in, you know, somebody else's situation, somebody else's place, that's anecdotal evidence, right? Anecdotal evidence is interesting. We should listen to it, but it's really not enough. And when it comes down to it with Agile practice, there actually isn't any scientific, coherent survey of the industry that says that any of these practices actually work consistently, right? I'm not dissing Agile. Agile's great, and we'll talk about that. It's just that almost everything people recommend with fervently is based on anecdotal evidence. And so that's not enough. We want to turn it around and start from the perspective of observation of our own process and our own problems before we get involved in what theory it is. And that was, Cervantes wrote his whole book 400 years ago about the same kind of thing, right? Where Don Quixote sees this dragon up on the hill and he goes charging after the dragon and everything. And it's just a windmill, right? He's just like, it's really the same problem, right? So Cervantes understood Agile problems before.
I think there's peyote involved in that.
And Sancho Panza knew all the time, you know, he knew that it was just a windmill up there. But he, you know, like, and that's like me, I'm down here, excuse me, sir, but, you know. So, so we have practices for debugging software are pretty well established, right? We set breakpoints in code. It can be really a powerful means of dispelling ambiguity. You run to a breakpoint, you stop, you observe the object state, the call stack that leads up to your question. We get it when it comes to debugging software. We should actually take that same concept and apply it to process, right? To debug our process, right? We have to actually develop vocabularies and techniques so we can try to figure out where the problems in our process are and how to fix them. And so the card wall is the metaphor that we use for modeling software work, right? That's the commonly accepted metaphor. So a lot of our discussion is going to be around this, how we do things on the card wall. We use them to like try to understand, you know, what's going on in our project, where things are, what we're trying to get done. And so, you know, if we have this idea of debugging process, then there's an assumption in that we actually understand what constitutes a process bug, right? A software bug is obviously it's a bit more clear, right? It's something that breaks the build, or it's a behavior that doesn't meet some kind of specification in some way. We have some idea what it is, that we have an understanding of what it is. But I think with process bug, if we don't clarify it, it becomes more of this mushy thing. I was just saying, here's a process, we want it to be, what does that mean, right? once we get kind of a better picture around what we mean by process bug and how we model our process, then we can identify really where inefficiencies are in our system, where problems are coming from. And then from that point, we're in a position to begin to consider what practices we might adopt that are going to help us solve these problems that we now know that we have through observation. And so best practices provide a shared idiom to exchange ideas, and that's a good thing, right? We want to use best practices, and we don't want to have to invent everything ourselves. It's just that we want to make sure that the practices we're actually adopting for some reason. I can't tell you how many times it's like something breaks in production, and then the next thing somebody's saying, oh, we're going to do test-driven development now. And I'm not against test-driven development, but it's like you're talking about, like, for an organization, you're talking about an investment of like tens of thousands, $100,000. Like, these are big investments to say this practice, and there's other practices you might adopt. Why that practice? You know, why? And especially since it was driven out of a problem for which TDD probably wouldn't actually resolve the problem. You could probably do something a lot simpler to address the specific problem that you have. So we'll take a step back, right? Because language matters. So let's talk about what we mean by agile, because people use this term in a lot of different ways. And if you read about it on the internet, you'll just end up going down a wormhole of all these different views of it. And so for my purposes here, really, we're just talking about the 2001 Agile Manifesto. It's a statement of 12 principles, right? You don't need a PhD in order to, like, comprehend it. You don't have to study it at end, and you do not have to have some expert come and tell you what it is, because it's just 12 principles on a sheet of paper, right? You can print it out on one letter-sized piece of paper, post it up against on your wall, and use it to reflect on as a set of principles to help guide your judgment, right? And so we get caught in this trap of, like, you know, we think that somebody else knows. It's the imposter syndrome. Right? We always think somebody else knows what it is that we don't know, but in fact, nobody really. You know, everybody's got a bit. Everybody in this room knows more about some aspect of software development than I do, or each other, right? We all have bits and pieces of the puzzle, and the Agile experts tend to, like, we put them up on a pedestal. They talk. We're back there not commenting, thinking that we don't understand. Just go back to the statements of principles and think through it yourself from this. You know, the Agile Manifesto appeared in 2001, so in a certain sense, not that long ago. And it came about in a context where the project failure rate was really high at that point, right? It was like 80% of IT projects or something were not delivering. And a best practice at the time was to try to control things by specifying everything up front and then locking down change management to prevent stakeholders from changing anything once work got in motion, right? And people go to conference and explain to you why it is that this is the case. And I remember I was at a conference in New York in 1999 with Grady Booch spoke. It was UML World, and he said, once stakeholders first see executable software, it changes the perception of what it is that's needed. And so if you're going to build what's needed, then you have to build an executable prototype and deliver it so that they can see it, so they can tell you what they actually want, right? While you still have some money to do it. And so this was the kind of observation. Grady didn't make it. He wasn't one of the signatories up there. That's the circle of the pantheon of the gods of Agile signatories, right? But these are the kinds of things that went into the emergence of the Agile Manifesto. The Agile movement grew out of lean manufacturing, right? Lean was, like, long before Agile, and it is the underpinnings of Agile. Lean puts a lot of importance on reducing waste in the system, and there's all these formalized methodologies in Lean, like Six Sigma and Lean Enterprise and all this stuff that were, again, it's like PhD material. When you start wading into it, you think that only somebody that dedicates their life to this stuff could possibly really, truly understand it, right? That you have to defer to an expert. But when it comes down to it, there's just a handful of principles that you can reflect on your own without reference to an expert. And that is identify what creates value from the perspective of a customer, understand the process that creates that value, make that process work, right? Make the process flow, and focus on identifying waste throughout that, and do that in a cycle. It's going through. And so again, Six Sigma is this gigantic, massive specification that's used in enterprise. And mostly all it does is it provides cover for management to have all of this extensive discussion about how they're doing this important thing when all they're doing is, in the end, is they're just going to blame their employees for not, getting the work done. So lean practice was pioneered at Toyota, and it was championed in the West by this guy W. Edwards Deming. So this guy here. I don't know if you don't know him, you should read about him. And he worked with Toyota in the post-World War II period. So MacArthur brought him over, and they stood up Japanese industry. Toyota was already in this culture, this kind of, they weren't calling it lean, but it was like they were in this culture of continual improvement already. It's a really interesting story. I went to the Toyota Museum in Nagoya, Japan, and it kind of tells this whole arc of the story that goes from the 18th century to current time. But Deming is the one that brought it to us. And he wrote a whole series of books. There's a whole pile of them. And his books were the cornerstone of this 1970s just-in-time manufacturing movement. And then he wrote this 1982 book, Quality, Productivity, and Competitive Position. And that's the one that really has the perspective of lean theory about the time when it was being picked up in the software industry, right, in that context. And it's not about software. It's about statistics, and it's about quality and productivity. So lean principles are intended to help us better understand the work and reduce rework. He talks a lot about that, right? And to reduce rework and wasted effort and to improve the value of the end product. And so Agile is a set of principles that helps us build the right thing, right? That's kind of really the main focus of Agile, what it's all about. And Lean's a set of principles that help us keep our efforts aligned with outcome. So together they focus on delivering value, so they're really just complementary systems, two sides of the same coin. And again, you don't have to dig into some big implemented practice in order to really grasp the stuff and apply the stuff on a day-to-day basis on actual decisions that you're making. But since we're talking about practices in this talk, right, I wanted to make this distinction between principles and practices. We have the principles of Lean, the principles of Agile, and we're going to go into talking more about practices, which are more intensive. And so the way that I'm intending these terms is that principles are things that you can reflect on, and practices are things that you can implement, if that's a useful distinction in there. So, for example, the first principle of the Agile Manifesto is that our highest priority is to satisfy the customer through early and continuous delivery of valuable software, right? It's a great principle, right? How could you go wrong, right? If you just step back and reflect on that and you say, how does the decisions we're making right now stand up in the face of this principle? That's the principle. That principle is the inspiration of a technical practice that goes by the same name, continuous delivery. And then we can talk about implementing that. And the canonical reference for continuous delivery is Jez Humble and David Fairley's book, Continuous Delivery, which is a big, thick tome. And it would take you could read it in a couple of weeks, but it would take you a couple of years really to digest the content in it, I think. The practice of continuous delivery is a lot more than just DevOps, right? We reduce it down to saying CD is DevOps, really, but it's more. It encompasses the entire business process from end to end, including non-technical people. And so it's a really very big undertaking. And as much as I recommend that you all become CD experts, right, and CD practices, you don't have to build a whole CD pipeline in order to reflect on the principles of continuous delivery. Make that distinction, right? Because you can own the principle in your mind today, right? You can't own the practice for a long time to come in almost any organization because it's really a lot of work and there's a lot of resistance to overcome. So that's kind of the foundation of the talk, just to lay down that all of what comes is it's on this foundation of Lean and Agile, but that Lean and Agile don't have to be something that's out of reach and out of touch, right? There's something that's accessible that we can reflect on. And I think we've established that we're going to build a model of our process so that we can observe what's going on in our process. If everybody here is in business already, you're already doing work, you already have a process, whatever it is, right? Even if it's not a defined or formal process. And what we're trying to get at is how we can go about building a model that provides an indication of where we're losing value, right? How do we suss that out, right? Some things are pretty obvious, but many things aren't. And so lean gives us a vocabulary to refine our understanding of different kinds of wasteful activities. And so if it's effectively a taxonomy of waste that lean provides. And so we can use this to classify our observations and use them as those observations as a basis to begin to select practices. Right now, in lean manufacturing theory, I think they talk about like 7 different categories of waste, and mostly in software we talk about these 3 that are here. And we use these Japanese terms because it comes from the Toyota practice and everything. I'm not sure how useful it is to talk about the Japanese terms because I can never remember which is Muda, Murray, or Mura. But they're conceptually they're easy to understand, right? Non-value adding activities, right? When you do things that don't add value, then those are things that you shouldn't do. It's pretty self-evident, right? Wasted effort due to overburdening, which is cut off on the slide there, and wasted effort due to unevenness and inconsistency. So now we can kind of break this thing down to say we're not just trying to eliminate waste, we're trying to categorize and classify where we're losing time and money in our process so that we can figure out how to fix it. So we'll walk through each of those. The classic examples of non-value adding activities, this muda, are building features that are never used, like a bricked over window, right? Gold-plated features, which I tend to do. I always want to build more than is actually needed, right? If you just build what's actually needed, then you'll have time later to add on more. Unnecessary complexity, Rube Goldberg type solutions, these would all fall into the category of muda that are pretty obvious. More subtle forms may be, where does this fit in? Like time spent on planning stories that are abandoned, right? So you spent time on the stories, you abandoned the stories, so obviously that work wasn't delivered, but you really have to think through the circumstance, because if the reason you abandoned the story was because through the process of doing the discovery on the story, you learned enough about it to realize that you shouldn't do the work, then it's not time wasted. It was time that you had to do in order to get to the point to know that you weren't doing the work. But if you find that you've got stories that you put planning effort into that were abandoned, that in retrospect you could see that never should have had the priority to have gone into planning in the first place, right? There were obviously dependencies that hadn't been resolved, that should have been resolved before that time was spent. That's wasted activity. And so you have to you have to look at these, begin to identify, where you've got time that's that's not really accounted to value, and then try to classify it into these different categories. And then over time, then you can begin to see where the big losses are, and then you can try to figure out how to adapt your practices to plug those holes and get to a little better efficiency. So overburdening is the really big one, right? This is the scourge of modern software development. I don't know about the world you live in. In the world I live in, it is just ridiculous. Like everybody is totally overtaxed in what it is that they're doing. Maybe it's a scourge of modern life in a way, right? And for context, the lean theory displaced a previous manufacturing theory that was the early part of the 20th century. This Frederick Winslow Taylor, right, who was like the Ford Motor Company assembly line, all that kind of stuff. And their whole theory was that management was supposed to scientifically maximize the capacity of each worker unit and every detail, right? To get the most out of everybody that they possibly could, right? Getting it down to like study their hand motions to like figuring out. And so the whole thing was about getting workers into their maximum capacity state, right? And then lean theory came along and said, no, actually, operating at maximum capacity just means that whenever something happens, then you're gonna end up in a wasteful state, right? Because you're going to have defects that require rework that could have been, and that's what Toyota was doing. Toyota was trying to operate under capacity, so when something happened, everybody would just stop and look and figure out what was going on. They'd have time to do it, and as a result, by the time you got to the 1980s, General Motors needed a federal bailout to stay in business, and the Japanese cars were taking over the industry for quality. seeking maximum throughput is what we're actually trying to get to, not maximum capacity, right? I'm not trying to make a moralistic argument that we should be nicer to workers, although that's a good thing. But it's to say that just from a business perspective, what you really want out of your pipeline is the maximum throughput, the most delivered value, and you're going to get the most delivered value by not overburdening your work. And so we've got a lot of work to do on this front because it's just so easy to fall into it. Okay, and then you have mura, which is like from Japanese, it translates kind of into either unevenness or inconsistency. And so it's kind of the most obvious examples that come to me on this have to do with, say, for example, problems that are introduced from a local dev environment that's not consistent with your production environments, right? It's like, it's an unnecessary problem, right? It's a solvable problem. It's part of the unevenness of your system. The same thing of when you deliver, say, a UAT to an incorrectly configured server, right? And then you schedule a whole thing, and the stakeholders come in, they look at the product, and it fails on different points only because the server is misconfigured, right? So you lose a tremendous amount of time and money potentially just by having made a mistake on configuration. That's avoidable. And so DevOps is a really natural remedy for a lot of these kind of common forms of mura. But again, the stuff that we're really going to be interested in are the more subtle ones, such as stories that are returned to work from bugs, right? Like why does something go back? Why does something get reworked, right? Where it gets delivered and then it comes back to get reworked. Is it because we missed requirements, because the requirements weren't understood, because there were edge cases that nobody had considered, because somebody changed their mind about what it was, because the tester didn't understand what they were testing? There's like a whole array of different reasons, and that matters, right? That's what matters in the process, is actually getting at those reasons so you can give a pass to those kind of bugs that come back to rework for kind of more or less legitimate reasons, and concentrate on those that are really avoidable, right? That are part of they're like a failure in your process that caused this rework, and the rework, your time and effort was going into reworking something rather than doing new work, which is where we want your effort to be. So that's kind of like part 2 of this talk, is to get into this, like the taxonomy of waste, and how these 3 vocabularies are just kind of the starting point, right? And then from below this, you can begin to build out your own taxonomy to classify and categorize whatever it is that you're facing, right? Wherever you're seeing issues in your work, to think through, to try to figure out how to categorize it and classify it so you can understand it a little better, and to communicate to others what's going on. And so now we can kind of go forward to this next step, right? And this is a great quote because it goes with almost everything. So we have this context now. We can talk about project management, work scheduling, and release management as like kind of 3 different areas of work, right? If you're a really small team, you're kind of like doing it all, sort of just doing it. But the categories exist. And if you're on a big team, then you've got kind of more clearly defined lines between these things, at least you should. And a really good way to get your whole process tangled up, right, to lose a lot of value, is to conflate project management work with work scheduling, and to conflate work scheduling with release management, because they're kind of like, they're all interrelated, they all depend on each other, but you have to sort these things out in order to make the stuff work. Project management's where you're setting your strategy for time, budget, and scope. And so even in an agile context, usually on a project management level, we're still dealing with a fixed number in many cases, right? We still have to say, we've got a $30,000 budget, or we've got some fixed budget. It's not like the budget is agile, right? You've got a budget allocation. You've got a client that's willing to spend up to a certain amount. And then once it goes into work scheduling, then we can talk about an agile process where we're going to try to figure out how to get the most value out of that spend over this time. That's really where you're going to work out the tactics of how you're going to accomplish those goals. And then release management is where you're going to deliver on those goals, and that includes setting stakeholder expectations. And getting that, the release management and the work scheduling mixed up is a great way to lose time and money. And people do it all the time by expecting developers to make commitments for delivery of work when actually all the developer can do is actually complete the work. And then there's this whole other kind of like array of dependencies that's typically outside of their control in between the completion of the work and its delivery to production, right? And so that's release management, right? And obviously there's the dependencies in it, and we have to have estimates, we have to know some idea of when work's done, but they're two different things, right? If you try to do both at the same time, then you'll just end up losing time, not saving it. And so our focus really is going to be around the work scheduling piece of this, right? Project management, work scheduling, release management. And work scheduling, because that's kind of the basket where most of what we talk about best practices from a technical perspective are kind of in this work scheduling domain. And so there's like a number of really common approaches that you're all probably familiar with, right? There's waterfall, where you plan everything from conception to delivery before starting. There's Scrum, where you batch work in time-boxed iterations. And there's Kanban, where your iterations are not time-boxed, but you set the amount of work in progress limit. You limit the amount of work in progress at one time. And then there's any other ad hoc or bespoke system that you could use besides these, right? And so before we go into the familiar ones, it's just worth saying, if you've got a bespoke system and it's working for you, then you don't have to go like surrender yourself over to Scrum jail just because everybody else is there, right? If it's working for you, then make it work. And if somebody says that another system is going to work better for you, then you need to match up, what your goals are, what your problems are, with what that has to offer, and make a decision about whether or not that actually makes sense. And this is one of the most common traps that teams fall into, where management sees a problem in development. They're not like they release management's not meeting expectations. And so they say, we have to make a change. So they say, okay, we're going to start doing this practice, right? You're laughing, right? And then you go, we're going to start doing this practice, right? And then it's like, the practice, it may be a good practice, but does it come in contact with the actual problems that you're actually facing, right? So I can tell I'm not the only one that's gone through this a bunch of times. So before we abandon waterfall altogether, right, the thing that everybody says is the terrible thing we're trying to avoid, really, waterfall can be a perfectly appropriate methodology, right? If you've got a relatively small project, it's in a well-known technology and domain space, it's a client that's got a really definite objective, especially if they've got like a fixed budget, then it could be the perfectly appropriate system. The problem it's trying to solve is achieving predictable outcome by controlling all of the project variables. And it's good work if you can get it, right? If you've got a project where you can control the variables, why would you do it any other way? It's a great system. It's just that, most of us we're familiar with stuff that's, it's more dynamic. The requirements are going to change. We can't control the variables. We need to have some kind of scheduling system that's going to do it, where we can adapt the resources to changing priorities as they emerge. And so that's mostly what we're familiar with as we go through. So Scrum, right? Everybody's familiar with Scrum, right? Scrum, right? Scrum's taken over the world and everything. And it's interesting to note that Scrum precedes Agile, right? Scrum dates from the 80s, right? Scrum was well established in certain circles anyway by, the Agile Manifesto, didn't come out until 2001. So, and a lot of people kind of conflate the two. They think of Scrum as being the manifestation of Agile, where in a sense, all Scrum is, well, not all it is, but I mean, if the most important aspect of what it is it's a work scheduling system. It's not a comprehensive methodology, it's a work scheduling system. And particularly when you try to make Scrum a release management system at the same time, then that gets really, I think it's like, makes things very complicated. But so basically, Scrum's typically 2-week cycle of iterations. That's what most people, it can be any period, but most of us are using 2 weeks. There's a specific set of prescribed meetings, definite defined roles, and an array of prescribed core practices. And that's the other mistake people make in Scrum, is they say that they put in a 2-week time box, but they don't actually go and, read what the Scrum specification really is, because it actually matters, right? Just throwing the time box on doesn't make it Scrum. So the important parts that, Scrum is trying to solve the same problem as Waterfall, right? It's a predictable outcome, right? That's what we're trying to get at. And Scrum tries to do it through dogged persistence at incremental accomplishment, right? That's Scrum. And putting the most important problems first, right? Prioritization. And that's where the rugby Scrum metaphor comes from. Moving the ball down the field, never giving up ground, right? And it's got its value in that. So in contrast, Kanban doesn't have any time box sprints. It doesn't mean we don't do sprints in Kanban. It just means we don't have time boxes. Or we don't have time boxes like on the whole process, right? We can put time boxes on work in Kanban, just not like a fixed time box for everything. Instead, the work is batched with work in progress limits or WIP limits that are coordinated by buffer and pull policies. And that has pretty important implications when it comes to release management. And again, it's like a pretty common thing is because in Jira you can pick a Kanban board, right? And all it means is you've got a card stream without a time box. And I mean, just because Jira calls that a Kanban board doesn't mean that that's Kanban, right? Kanban is actually, it's a process, right? It doesn't have nearly the prescription that Scrum does, but it is a process, and it's worth following through what that is. And I'm not going to go into detail on it. But the problem that it's trying to solve is predictable outcome, right? Everybody's after that, right? That's the only thing that really matters in the end. And but with Kanban, it's really by emphasizing the strategic advantage of focusing on quality over maximizing capacity. That's a core principle in Kanban. So the Kanban metaphor is that of traffic control, right? So Kanban in Japanese means signal card, Kanban, right? So that's what this guy is right here. So the whole idea in the Kanban system, in the Toyota manufacturing plant, they've got these cords everywhere in the plant, and anybody from a manager to the guy sweeping the floor and the factory workers can reach up and pull the cord. And when they do that, then within seconds, somebody has to be over there, a supervisor, to look at what they're looking at, what the issue is. And if they can't resolve the issue right then and there, they pull the cord a second time and the entire factory shuts down. And how often do you think that would happen in an auto manufacturing plant in a day? Like a few times?
5 times.
Or maybe like 1,500 times in a day? Wouldn't be unusual, right? It's like it's pulling the cord, stopping the line is not a problem in a Toyota plant, right? Whereas in a GM plant, they would fire you for it.
The idea there is that risk mitigation is more valuable than...
Risk mitigation is more valuable than maximizing productivity. So the whole idea is to call attention to what's going on in real time for the team to come together, make things right then and there. So Kanban, the work in progress limits provides this incentive for the team to pull together to unblock stories. And it's not like you can't do this in Scrum, right? It's just that in Scrum, if you've got a bunch of people, they're working, everybody's got their car, their stories, they're working on the stuff, something gets blocked, usually what happens is it becomes like a rock in the river, right? The blocked story just sits there and all the work flows around it. Whereas in Kanban, that story is blocking new work from coming in. And so you either have to move that story out of the Kanban board, and in order to do that, you have to get the product owner in to agree that this story can't be unblocked. Or the team, this team swarms on the block card to say, okay, what are we going to do to move this thing forward, right? And so the Kanban system provides this kind of natural incentive to make sure that everybody goes forward. So here's another great Deming quote. Improve quality and you automatically build in productivity. So it's a good quote, but what does improve quality mean? Right? In process, right? We know in product and we can say, but in process, how do we improve quality, right? And in software, we use this term QA that's considered synonymous with testing. And the tests are proof of compliance with requirements. And it's really a very narrow conception compared with how the term is used in manufacturing. And practices that prevent the recurrence of defects is more consistent to what we're after here. For example, in software, if ensuring that all the stories that coming out of work meet an agreed upon definition of done is a quality assurance practice, right? You're not doing quality verification. What you're doing is you're putting a practice in place that everyone follows, and everyone follows the practice, that the result of that practice is going to be less defects and less rework, is the theory of it in any case. What the testers are doing is quality verification. And so we have this namespacing problem because in the software industry, everybody understands QA to be quality verification, and it doesn't leave us any language space left to talk about quality assurance without having to go into a big explanation to try to distinguish QA from quality verification. And there's no one doing that. No way are we going to get people to think of QA as being anything other than testing software. But that's a lot of what this talk is about, in a sense, is process debugging is the result of process debugging is adopting practices that ensure quality assurance practices, right? Those are best practices that for your circumstance, for your team, for your product, those practices that reduce defects and reduce rework and keep the focus on the work, those are your best practices. And nobody else can tell you what they are without observing your process. And so quality assurance starts with the observation of the process to try to better understand the work, identify where inefficiencies are coming from. When you break the build with code, you know what to do, right? You have to find the code, fix the code, push a commit, and get the build green. But wasteful activity in process tends to be a lot easier to overlook, right? So it's more like think of it more like a software bug where you can't tell what it is, and you need to set a breakpoint, step through code, observe object state change. And so for process bugs, we need to get the problem that we're looking at in the context of its progress through the system in order to be able to actually understand what practice would help assure quality going into the future. And so again, another great Deming quote. I didn't start off with Deming quotes, but the more I went in, it was just so appropriate, right? So building a model is what gives us a starting point for observation of the system. That's why Cardwall is so much more than just putting the stuff up on the board about what's going on, right? It's the way that we understand how to fix and improve our system. Without a coherent model, then discussion of defects and other problems is inevitably going to focus on the task or the worker, right, and not the process, right? And the Deming quote here is 85% of the reasons for failures and deficiencies in the systems are in the systems and processes rather than the employee. And the role of management is to change the process rather than badgering individuals to do better, right? So I think most of my Fortune 500 software career is about being badgered to do better, right, in processes that are broken. So finally we get to Cardwall, right? And so I pulled these out of this book, Kanban Maturity Model, excellent book. You could use a lot of the same principles in Scrum or without Scrum or Kanban, but the idea of just setting up some columns to put up state. You're representing your features, stories, and ideas as cards as a way of abstracting independent ideas and drawing relationships and dependencies between these features and communicating this to other people, right? And so you could use this one in any ad hoc process. Now, here's a little variation, right? So all we've done is in the development column, we've drawn this dotted line to indicate a done status. And so it's just like a minor detail, but it begins to illustrate that the way that you model in detail actually is important to what it is you're communicating about the work, right? And in this case, what you're doing is you're modeling the difference between a push system and a pull system. And mostly in Scrum, we see people using push systems, whereas Kanban really specifies a pull system. And the difference is that it's not that big a deal, but I mean, in a push system, when the work is done, then the developer will drag the card from development to build ready or ready for review or whatever the next state is. And it's in that next state, and so it's ready for somebody to pick up. In a pull system, it stays in development with a done status set, and then it is ready to be pulled in. So it actually doesn't make it into that next state until it's actually being worked on. And so by doing this, you're simply communicating to somebody outside your team or even within your team the difference between work that's ready to be looked at next from work that is being looked at, right? So one less thing that you have to talk about. So here's, let's look at a Scrum board versus a Kanban board so we can see that it's really not that big a deal. And both Scrum and Kanban are going to have a product backlog, some backlog of ideas that are like things that you're going to pull from. And then in Scrum, you're going to have a sprint backlog. So at the beginning of your sprint, you're going to sit down, you're going to pull together 2 weeks worth of work and put them in the sprint backlog. And those are going to have to be reasonably well decomposed, not necessarily fully analyzed, but reasonably well decomposed and kind of more or less ready for work. Whereas in Kanban, the input buffer is conceptually the same space as the sprint backlog. So, but instead of saying every 2 weeks we're going to batch 2 weeks worth of work, we're going to say we have an input buffer of 5 stories or 8 stories or whatever number you come up with that's right, and that you're going to hold the equivalent of a sprint planning meeting, a smaller one, whenever necessary to refill the buffer, right? Because you have to have some starting point going through. And so in both systems, you're trying to distinguish between generalized idea work in your backlog from work that's actually been vetted, right? So everybody agrees what should happen with. There should be like acceptance criteria in it of some form at that point. Not necessarily completely analysis complete, but in both systems, again, the input buffer and the sprint backlog are conceptually the same thing, and the rest of the board can be the same, and then the numbers across the top would be the work in progress limits that you place on your Kanban board to say that you can have no more than 4 stories in development status, or whatever number you come up with. You can do Kanban without setting your WIP limits, and just kind of start by observing WIP limits, or set really large numbers, and then gradually experiment to get the right numbers. So here we've added swim lanes, and you can do this in Jira and probably a lot of other systems, right? In this case, we're using swim lanes to model types of work. And you can think of types of work as another taxonomy. It's giving you a way to differentiate attributes that distinguish one type of work from another. So here we have, if what your team is seeing is like your basic work are these change requests going into a product, and then you've got like maintenance tickets and you've got production defects, right? And so instead of having them all flow across the board, you can drop them into swim lanes, and it just gives you a way to visualize the work a little better so you can understand what's going on, right? So for example, if the test protocol for production defects is a little different from what you do for a change request, then this helps kind of like keep everybody in sync to what's going on. And again, it's just one less thing that you need to talk about as you're going forward. And so here we've added classes of service as yet another taxonomy. And this is just modeled as card colors, right? You could do them as, you could switch, you could use swim lanes for one, card colors for another, but the idea is some way to distinguish. And so the classes of service that are shown here, this specific taxonomy is from that same book, Kanban Maturity Model, in which Anderson recommends standard, fixed date, intangible, and expedited as sort of a baseline set of classes of service. And so standard is your regular work that goes through. Fixed date is really just like standard work, except it's work that that's going to drop dead on a due date, right? Not just your regular project date, because everything's got a due date, but something like if you don't deliver by an election or by Christmas or by a sporting event, then there's like 0 value for this work, right? It has to get done by a specific date. And so the behaviors of standard and fixed date work start out the same, but as it gets closer to the burn date, then the fixed date work starts to take on different behaviors. And so bottling it in the system, it means less that you have to talk about, more that's in the model. Expedited work is self-explanatory, right? The stuff that, especially if you're doing Scrum and you're in this thing where it's like, we can only do the things that are in the backlog, and then the expedited work gets thrown into the sprint, right? And everybody complains, but at least there's a way to model it so everybody can see what's going on, they can see what the state is. He also defines this intangible. And intangible is a class of service where there's like not real, it's hard to pin down like what the loss would be at a specific date, but there will be a loss if the work's not done eventually. You can always kick the can down the road on intangible work, but sooner or later you've got to do it. And so refactoring tasks are the classic ones. There are probably other like that, right? You can always kick the can down the road, but sooner or later you'll pay the price if the work doesn't get done. And so by modeling intangibles differently from the other work gives you a way to like see that, well, like when you find that the intangibles are never on the board, then that's an issue that you have to deal with. You have to change your practice in some way to get that in.
That would be migrating to the next version of Drupal, or to the next revision of Drupal, going to 8.6 or 8.5.
Yeah, depending on what your dependencies are, that could either be fixed date or it could be intangible. If your system's gonna die because of not an upgrade on a date, then that's the fixed date. But if it's
until 6 months from now.
But every day you miss the date, every day you put that off, you're digging yourself deeper in the hole, right?
So just real quickly, is the concept then to like prioritize intangibles at some percentage of the total velocity of your project at that point in time? Like say like, okay.
Well, so now you've gone about specifying what might be a practice that you would put in place, like quality assurance practice, right? So whatever it is that works, right? The first thing is through observation of the system to identify what your problems are, right? And then once you draw a circle around it and get everybody to agree that this actually is a problem, then you can discuss what is it that we can do to solve this problem. And if you go to the internet and you search like, agile best practices, you're never going to find anything that solves that problem. You're going to find these big, giant theoretical things that you should be doing as best practices, but they don't actually deal with your actual problems, right?
In some cases, it becomes queuing theory where you're saying, oh, look at all these purple things that are stacking up because all these other things are going through it. We just have to allocate some time to get the purple things down.
So here is I like this, the overburdening is really, obviously it's a big thing for me and a big thing in my life, right? And so I wanted to look at it from another perspective. And that's this thing where I hear, particularly the CFO, right, is the one that I hear this most from, right, where they say, well, we're a $12 million agency, right? And what they're intending to say is they can do $1 million worth of work a month, right? $1 million a month, right? But kind of more often than not, they're actually talking about how much work they can sell rather than how much work they can deliver, right? And so your capacity isn't the amount of work you can put in motion. Your capacity is the amount of work you can finish and deliver. That's your capacity, right? And the thing is, we live mostly in a world where the developers are the ones that have to live in this world where we can't, we're overburdened and we can't deliver what's pushed into the pipeline. And then on the other side, there's not a recognition of this discussion right here, and more work gets pushed in. And as long as you're operating the pipeline at maximum capacity, then every increment of new work that gets pushed in is going to be overburdening at that point. And it's going to result in defects and things coming back for rework and mistakes that are going to impact your throughput overall. The throughput of the pipeline is what we're trying to get at, right? And pipeline management, it's a science. That's why they blew up all those houses up in Massachusetts, right? Because they overburdened the pipelines, right? So I've got a section here on time, and I'll just blow through it really quick and to say, Scrum specifies 20% of your time for meetings, right? The backlog refinement, the mandated meetings, the prescribed meetings of Scrum, 20% of your time right out of the box, right? And if you're using Kanban or you've got an ad hoc system, you're going to have the similar stack of meetings, some profile of meetings that fit into the same kind of categories of meetings. You're going to sooner or later you're going to have some kind of retrospective. You may do less time, you may have a different mix, but you're going to have some mix like this. And the amount of time, this is called coordination time, right? But it's not all of your coordination time. Every time you have to stop and ask for clarifications on requirements or any number of other coordination activities, that's also coordination time. And so so here's this conception, right, that you've got out of 100% of time available, and this is already discounting doctor's appointments, vacations, and everything, right? This is just the time the team has available to do work. Out of that 100%, you're going to have coordination activities, staging activities, and work on task. And coordination and staging activities are necessary, they're essential. If you shortchange them, you'll end up paying the price down the road. But your wasteful activity, muda, mori, and mura, a lot of times you're only going to know that you have wasteful, the first sign that you have wasteful activity really is going to show up kind of indirectly here, right? When you have this sense that you're spending too much time in meetings, right, and you can't get any work done, then, at a certain point, you've got to be, somebody's got to do the work, right? You can't just have everybody coordinating everything all the time, right? And so it's not going to be clear where the problem is. It's not even going to be clear where the time's going because nobody's mapping all this time. There's no way to map all the time. It's going to be more the general sense of things because not all the time is formal meetings. Some of the times are the informal meetings, calls, and like ad hoc meetings that you have to have. But when you get the sense that the coordination and staging are like deploying stuff to servers and getting the work out, setting up local dev, all that kind of stuff. When you get the sense that too much time is going in those areas, then you need to try to figure out where that's coming from, trace it back, categorize it, classify it, figure out what your taxonomies are to organize the stuff, find the parts that are doing the most damage, and then talk through practices that are going to remediate that. That's solving the problems that you actually have. And then just kind of to close out, here's one of my favorite of Deming quotes, just so you really get a sense of this whole thing, right? So here it is. This is W. Edward Deming's, right, in like 1975 or something, or 1980. I don't know when this quote was exactly, right? The prevailing system of management has crushed the fun out of the workplace, right? And this actually aligns with the Agile principle of we favor self-organizing teams, right? Because and one of the way how this thing gets manifested in the workplace is where developers and other people in the team are told what to do, and they're told how to do things, right? We're going to be using this system. Here's our practices now, and if you have a problem, if you're having a problem getting your work done, then it must be because you're not following the system, right? And that's what Deming was and that was what was going on the factory floor, of course, crushing morale. And so you want to get to the point in a workplace where if the individual team members on every level have a sense of empowerment for identifying wasteful activity and acting on it, then it'll have a natural effect of raising morale and actually getting the work done, getting the problem solved. So here's a little bibliography of some of the books that went into the train that led up to this. I put in that Unified Modeling Language reference manual. That was from the 90s. Right before Agile, we did UML, right, where we drew pictures of everything. It didn't really do as much as we thought it would, but those were the days. Deming's book, Quality, Productivity, and Competitive Position, which is pretty cool. It's kind of like a lot about statistics in a way. It's kind of a dry read, but it's also he makes these kind of comments about quality and morale and where the responsibility lies for getting stuff done. So I still think it's a really relevant work. And that book, Quality, Productivity, and Competitive Position, is basically the foundation on which Jez Humble's book, Continuous Delivery, is sitting, right? The Continuous Delivery book wouldn't exist without Deming's work. The Phoenix Project is a novel about DevOps, so that's really a fun read, right? You should read that over Thanksgiving or Christmas. And then the Kanban books are both excellent. If you're starting out, you want to do the blue one first, just Kanban, Successful Evolutionary Change. And even if you're not going to do Kanban as a system, you're going to learn a lot about process by thinking through it in the Kanban way. So even if you have to do Scrum in the workplace, or even if you're just going to use whatever process you're using, you'll learn a lot by seeing how Kanban sees it. And then the Kanban maturity model is this kind of bold effort to reset a vision of how we look at process overall. So it's kind of like trying to step on top of the space that the CMMI management protocol is, the centers of excellence and all that kind of stuff on the enterprise level, to put it in a context that actually makes sense for developing the maturity of an organization to consistently improve the process, to end up with better throughput in the system, which is what we're after in the end. So that's where I've got my contact information on the bottom. On Twitter, I'm August 1914. On LinkedIn, I'm in Godeck. And I'd be more than happy to continue this conversation here and beyond. So any questions I want to come off this from here? Yeah?
I'm going to try to pick the best one here. Any specific process debugging techniques that you would like to call out as kind of your tried and true, there are methodologies? I don't know of any process debugging techniques.
Well, it's to build out your taxonomies is where I'm going to start, right? So classes of service, types of work, categories of activities and waste, right? And then start mapping it. The in Kanban maturity model, they really emphasize using different creative ways of using decorators on cards to try to call out these different types of behaviors that you want to begin to focus on, right? So as you're modeling the process, as you begin to suspect that you've got some kind of issue, then you create some decorator on the card. A little square box or a countdown or yeah, Jira's adding it in. Jira is kind of like Jira's like the Windows 95 of project management, right? Because it's clunky. It's hard to change. I find you can do most of the stuff that I talked about. You can do it in Jira, but at a certain point, it's like, at a certain point, if we could get to where we just had a digital whiteboard, and we did cards without these electronic systems altogether. We went back to free whiteboarding cards. And then we had a way to collaborate that. That would be to get it out of, because it's like Jira is like this database, heavy database management system, and we lose a lot in flexibility, right? What we want in process modeling is a lot of freedom to be able to change up the model without having it be expensive, and visualize it. Yeah, and what I find in Jira is that there's a lot of things you can do in Jira, but we never do it because it's just too much trouble to go in.
You guys haven't watched the webinar that they just released talking about their whole roadmap and what the whole new system is doing. It is tackling this very, very thing, because they built the system with Agile, with the capital A, right? And that was what they built. And now they've, over the decade plus that they've been doing this, they've heard all of these different, we need different types of things for different types of projects, but they all still need to be cohesive, and we don't need all these dependencies that make it brittle and break. And so if you guys haven't watched that yet, watch it. It was really, really impressed me, because I was on the fence whether or not we were going to continue to move forward with Jira, and just what I've seen in that demo, 1 hour demo that came out on Thursday, or on Wednesday. I'm sure you can go to their webinar. It talks about the whole new system. It very much covers some of these kind of problems that we run into when we're managing the backlog and planning sprints, and being able to quickly visualize where the heck are we? We've been living in 2-week sprints. But where are we in the grand scheme of things?
I have a really hard time telling what's going on the team I'm on.
So they focus on that. I got a couple other questions, but I don't want to interrupt anybody else's questions here.
Questions?
I had a thought about, you said that when it comes to process, there are things that we need to identify to kind of figure out if we're going in the right direction. I thought that one of them was to try to define what types of things are the things that would define as an applicate, or a process crashing, or what would be the undesirable outcomes to avoid.
Well, we can start with the desirable outcome, right? And the desirable outcome is the main thing that you're measuring is throughput in the system, right? The ability of your system to deliver value. And so it's the everything that like eats away at the throughput of the system. Those are the things we're trying to identify what they are. So we're kind of working our way backwards from the actuality of our process of what the team that we have and the work that we have and the skills that we have and the technologies that we have, the kind of problems that we're incurring in this circumstance that are eating away at our throughput. Draw a circle around them, because those are going to show up in time, right, somewhere. They're going to show up in time. They're going to show up in cards that get blocked. They're going to show up as dependencies that end up chewing up time, right, unresolved dependencies, concurrent activities that get tangled up, and rework. Rework is really, obviously, is a very big one, right? What do you do to keep, and that rework is a really touchy one, right? Because, a lot of times that's what it's like doing the rework is what you do want. I mean, when something's wrong, you want to do the rework, right? It's not like you want to like step on anybody. Like, why are you doing this rework, right? I've seen that a lot, right? Why are you having?
I think it's like the biggest aversion of people kind of coming into this process is that like they don't realize that this is not about particularly you creating a problem. It's about us identifying the problem and getting past it and reworking it. So like you kind of almost have to like preface when you're bringing people into this type of work that like, look, don't get offended if we identify a defect in your code or a process that you did. It's the fact that we were able to identify and communicate it and refactor it is the purpose of all this, and that you really shouldn't take offense.
There's a really great podcast on This American Life from years ago on, it's called NUMMI, N-U-M-M-I, and that's the General Motors plant in Fremont, California that Toyota took over in the 70s when U.S. Congress passed tariffs to punish the Japanese imports because they were so much better quality, right? And so it forced Toyota into a partnership with General Motors. And they came into this General Motors plant, and so Toyota meets General Motors. And it's just a beautiful, beautiful story. I won't say more about it here now. We can talk about it over a beer if you want, but I really highly recommend it because it goes into exactly the kind of stuff that you're talking about culture and
thought for future presentations. There's a classic problems of project management cartoon that starts off with what the customer wanted, which is a tire swing on a tree, and it goes through the various things, and finally what's delivered, and the middle of the tree's been cut out, and there's props up in there, and so basically what you're trying to do with process debugging is make sure every state, everybody has.
Certainly in Lean, it's one of the, is like making sure that we identify what the customer is looking for and delivering that value that's going through. And I'll say, just in preface, that I'm doing a session tomorrow on estimation, which is sort of a companion session to this one in a way, because process and estimation are like, they're really closely related kind of things, right? And I don't mean estimation as like, tell me when you're going to be done, right? Which that's what mostly I get, right? I've gotten an email in my inbox right now. It's like, tell me when you're going to be done, right? And my answer is, I don't even know what it is you're asking me to do yet. So, yeah.
What are you going to answer?
When am I going to answer? Yeah, I'm going to answer Monday morning, and I'm going to say, I will tell you in a week the things that I need to know in order to tell you how long this is going to take. Right?
Can you revisit quickly the difference between quality assurance and quality verification?
Sure. Quality verification is testing, a feature against a set of criteria, right? That set of requirements to say this thing matches that.
It's more like a task.
That's what we call QA in software, is quality verification.
More like a process.
Quality assurance is any practice that you put in place that prevents the recurrence of defects or other inefficiencies. Those in the manufacturing world, that's what we call quality assurance practices, right? And that's what we need to do. That's what process debugging or process management is a quality assurance process.
You could say that quality verification is a child of quality assurance process.
It's the guard dog at the door, right? But the purpose of quality assurance is to get to where you have very few failures in quality verification, right? to just make sure that the work comes out right the first time, right? And it goes that podcast about the Toyota experience in Fremont, California. It gets really, really interesting why in the end that failed, right? In their effort, because it has to do with the wider picture of quality assurance, right? It's very.
Thank you.
Thank you very much for coming out, and yeah.